So we can write a is equals to 2c, where the value of a should be any integer, positive integer, right? As we have seen in the theorem 1.6, the value of a is any positive integer, which we are taking as c. On squaring, we get a is equals to 2c. 2c is our positive integer. We'll square it again. A square is equals to 2c square. Now, we will substitute the value of a square in the above equation, where 2b square is equals to a square, right? Instead of a square, we will write this value 2c square. 2b square is equals to 2 2s are 4, c square as it is. We'll just cancel 2 1s are 2, 2 2s are 4, it cancels. Then b square is equals to 2c square. Now, if we send this 2 again here, it also divides b square, right? B square by 2. Similarly, how we got a square by 2 in the previous slide, which means 2 divides b square, then it also divides b, right? So, but this contradicts the fact that a and b are co-prime. How we should get this? We need the values of a and b as co-primes, right? As I already said here, these should be co-prime, but we only got 2. As we only got 2, which is not a co-prime, it is a prime number. So the contradiction has arisen. Why does this contradiction has arise? Because we assume that root 2 is rational. That is why this contradiction has arrived. So it means our assumption was wrong and root 2 is irrational, which is in general, it can be shown that root d is irrational. D is any kind of positive integer if it is not the square of any other integer. So what does this mean? Let us suppose root d is root 2. Is it a positive integer? Yes. Is the root 2 is the square of any other integer? No. Can 1 square makes 2? No. Can 2 square makes 2? No. So it is always irrational. Similarly, root 6, is it a square of an integer? No, it is not. Similar with the 8, root 15 and root 24. These are not the squares of any other positive integer. So these type of numbers are always irrational. For example, if we has root 9, is it a square of any integer? Yes, it is a square of 3. 3 square makes a 9. So it is rational. That is what this statement says. In general, root d is irrational whenever d is a positive integer which is not the square of any other integers.